All right, it's a snowy day in December, and we are working on problem 10 of the 2022 coding advent of code. And we got right up to this point at the end of last stream, so we will start here after being able to use our this program that they give you to interpret these as instructions and come up with the signal strength. So first half of the problem is complete. It provides 1 gold star. Part 2. It seems like the X register controls the horizontal position of a sprite. Specifically, the sprite is 3 pixels wide. I'm going to forget about that. The sprite is 3 pixels wide. And the X register sets the horizontal position of the middle of that sprite. Okay. In this system, there's no such thing as a vertical position. If the sprite's horizontal position puts its pixels where the CRT is currently drawing, then the pixels will be drawn. Okay. You count the pixels on the CRT, 40 wide and 6 high. The CRT screen draws the top row of pixels left to right, then the row below that, and so on. Okay. The leftmost pixel in each row is position 0. The rightmost is 39. Like the CPU, the CRT is tied closely to the clock circuit. The CRT draws a single pixel during each cycle, representing each pixel of the screen as a pound sign. Here are the cycles during which the first and last pixel in each row are drawn. Believable. Okay. So by carefully timing the CPU instructions and the CRT drawing operations, you should be able to determine whether the sprite was visible the instant each pixel is drawn. If the sprite is positioned such that one of its 3 pixels is the current pixel being drawn, the screen produces a lit pixel. Otherwise, the screen leaves the pixel dark. Got it. Okay, so we have 2 things going on. It's like a model and a view. The model can either be where a pixel is being drawn, or it can not be there, and it does light and dark pixels accordingly. Okay. First few pixels from the larger example program, blah, blah, blah. Cool. Allowing the program to run to completion causes the CRT to produce the following image. Render the image given by your program. What 8 capital letters appear on your CRT? Cool. I like this. Okay, and is this still the same example program? It is, right? Larger example program above. Okay. Fun times. Let's do it. So, first things first, let's update our example input. Oh, right, it's a file, and it turns out it can, as I expected, just be called example input 10. Oops, just example input 10. And we'll just change that in a few places. Let's see here. Whoa. Oh, that's where I found it before. Okay. Is that the only time I used it? No, I used it here also. Okay. Cool. So cargo test problem 10, and we expect 1 failure. And we got 1 failure. Okay. Cool. So now we need to presumably implement a CRT struct. Which also knows how to handle the clock cycles ticking off. So the CRT just goes. Okay, so two options here. We could have a separate struct for CRT that just goes. The thing I don't love about that is that it means we have to remember to pass in, like we have to make it tick forward kind of at the same rate. I guess we could have the CRT take the CPU instructions as an input. Like run the CPU, like have the CPU consume the instructions, and then have the CRT consume the CPU, kind of like a model view controller type thing, where the CPU is the model, and the CRT consumes it and goes through and knows how to render it. I kind of like that. Let's do it that way. It's not like the most object-oriented thing in the world, but I like it. Okay, so what to have our CRT needs to be able to, well, it's got to be able to render. And so let CRT mute CRT equals CRT new. So it's going to consume CPU instructions, but I guess I would also like to just be able to provide, let's say default. So we'll give it a default, but if we give it a new, let's we'll just give it a vector of no, I guess we don't. I guess we always give it instructions. I guess there's no world where we're ever running it without instructions or without the CPU. So render, let's say render, and we will give it a CPU. And we will assert that that equals something. And for now, I'm just gonna stick that in. And we'll need let mute CPU is CPU new, CPU.consume all. And for the render, I mean, I guess we may as well use the example input, right? So that's these. And then we render based on that, and we expect an output that, do I have an easy way to copy this output? Is it going to be a vector of strings? Yeah. It's going to be a vector of strings. Yeah, so let's just copy the actual output. And maybe we'll stick it in a function because we're going to want to use it in a few places. Get problem 10b example output. And we'll just do it like this. And I guess we'll need to wrap this in a vector. And we need to return something. Should be a back of string. Okay. And so now our render should return get problem output. Okay. And I guess we may as well do a similar thing for the for this guy. So we can say let example input be I guess it's just the same mostly. We don't need this, we need this. And then, so we take the example input, we say assert that the solve problem 10b example input should be the same as get example output. Okay. And it should, oh, it's gonna spell out characters. That's fine though. Is that fine? Yeah, because we're just gonna render it and look at the answer. Use my eyeballs. Okay. So this is fine. This guy is gonna need to return. That's fine. This guy is gonna need to return a vector of string, and it's basically going to be basically going to amount to doing this. This becomes just input. Trying to use better Vim shortcuts. And this will just be consume all and return. I guess consume all and then CPU.render. Sorry, CRT.render. And that'll return. Okay. Cool. And let's see, are there any other good tests we can write here? I mean, it's the CRT consuming that does a bunch of the work. So the CRT consuming is basically just going to run forward the render, or run forward the, it's really not even until it renders. Yeah, it's really just rendering. I think this is fine. I'm sure you could come up with some clever tests that do a better job and continue to drill in, but I think we should be okay here. So this will just be mean, really, this doesn't even need to be another struct. As I'm thinking about it, like, really, this is just... this could just be another function on the CPU. So this is entirely just for explicitness, but that's okay. Function new. And pub function consume. Turns nothing. And oh no, there is no consume. It's just render. It's just render. And so what to say here? So let screen be, let mute screen, is going to be a bunch of dark pixels, I guess. Characters. Let's iter repeat a bunch of characters. And then let's take CPU dot get cycles from it. I just want to take the history, actually. So CPU dot register history into iter. And now for each one of these, I want to map over the register X. I want to enumerate this. So this is going to be I comma X. And we're going to say what? We're going to have a little block here at the end of which we will collect. By the way, this needs to return. So I guess this will be a vector of characters, but then at the end of this, we will break this into chunks. So let's assert here that chars.length is 6 times 40. And then we can say return a vector that is chars of 0 through 40 non-inclusive, chars of 41 through 60, 80. I can do math. 81 through 120. Obviously, there are more generic ways to do this, but again, would help if I did my math right. 161 through 200, and 200 through 240, and I'm doing something wrong here. This should be 40, this should be 80, this should be 120, this should be 160. 160. Okay. And then we need this to be, can I just say toString? Doubt it. No, can't. Do iter join. Up so often, but I really have a hard time remembering. Okay, so any vector can be joined. So this could be collect vec join. Into iter. This looks okay now. Join exists for a vector of characters. It's trait bounds because characters can't be joined, apparently. What if I this seems like not the most idiomatic way to do this. Let's see here, rust concatenate chars toString. String.push does it. Okay. Or I can use format. Also interesting. So that means that I could do potentially format chars this. Collect that. Wait, it has a dot join. But trait bounds doesn't like it. doesn't implement display. Well, that's not going to work. And this doesn't work either. Fine, but I can clone into. No, we can just clone. It's a slice, it can't be cloned. To owned. Oh, how about to vac? Alright. Getting closer. And vac char doesn't work because char itself is not, or an array of char isn't joinable. Okay. This all seems very kludgy. I don't like. Do not like. How to do this nicely. Okay, so what if we use the screen? And we say pixels is a vec of string. And then new is self of a vec of string new 6 times. And then we have a private function called push. Which takes a mute self and a character. Sure. And a bool. And does not return anything, but what it does do is says finds the first one that isn't full. So self dot pixels dot next to, let's see here, self dot get next to add is lit. I mean, we can just use the symbols, or we can render the symbols. Let's render the symbols. Whoops, is equals is lit, and then this guy should be a vector of bool. And now get next to add. Returns a usize and says for that shouldn't be a list of bools though. It would have to be a vector of bools. Dot push is lit, and this will be a vector of bools. Yeah, so maybe let's just do the string. It's going to be simpler. It hurts my usual habits around not wanting to use, wanting to use bools or enums for two value values that can only take two values, but in this case, I think it's fine. So we will push self.getSymbol is lit, and self.getSymbol bool b for islet bool will return a char or a string, a char, and it will, if islet, then it returns a pound sign, and otherwise it returns a dot. Next to add will be for row in self.pixels. If row.length is less than 40, is equal to 40, then we return I. Let's enumerate this. And we need for I row. Let's also assert that row.length is less than or equal to 40. And then it loops, and it should never get here either. We just hit panic here. Okay. Get symbol is lit. Shouldn't be this self. Okay, and so now we can get rid of all of this. And the map becomes what? So if so we get the register history, and for each clock cycle, if it's if x is either +1 or -1 of the clock cycle, or equal to it. So x minus 1 is, x is within, so it's if x minus I absolute value. Is less than or equal to 1. Then self.push true, but it's really just self.push this expression. And then we don't collect this anywhere. And we don't really need to do that. We assert separately. We do need to return the rendering though, which is to say we just return self.pixels. And we don't need to do this. And we need this to be a for each. Okay. And I guess we'll clone this. And get next to add. What's wrong with this? Pixel self dot get next to add. Hey Chandu, you work with Rust for my job. I don't. I've mostly done Python and PySpark and data stuff for my job, but Rust is my favorite language, and it's the one that I like to use whenever I have a choice in the matter. How about you? What do you work on? There are no Rust jobs. Yeah, there aren't very many. It's true. It should be changing though. It's like one of the most popular languages. And I think there are some really compelling reasons for it to change. Like, I don't know, you compare it to something like Java and it's just wouldn't. You do C#. Yeah, C# another one that it feels like, I mean, I guess the Rust ecosystem isn't as mature as C#, but it seems like Rust could do the job. I'm biased, but what kind of things do you do with C#? So what's my issue here? I don't need to borrow it. Oh, I guess I do, don't I? Do this. Yeah, okay, that works. You want to use Rust to build mission critical code or implement algorithms? Sure. Those are good things to do with it. For C# you do ASP.NET web dev stuff. Yep, that's a thing that a lot of people do. I did some C#, not for work, just for fun, I don't know, 5-6 years ago. Was not my favorite language, but it was before I discovered Rust, so. Let's see here. What's going wrong? Sure. My answer is a vector of strings. Let's just make it nothing for now. What's the issue? Oh. I'm surprised it can't work that out. Okay, so we are compiling. Did the rendering already? Oh no, this feels a little bit iffy, but let's see how it goes. Yeah, test render is failing. It's failing because it's panicking on the panic, which is fair. So, is this just because it gets to the very last pixel? Maybe. Maybe. Let's see here. Do I have a nice way to figure out whether the input goes, let's see. So before we pipe this into our test, we can say, not this test. CPU, okay, we consume all the instructions, so we would want to say that assert CPU.getCycles should be exactly 4 times 60, and this is probably just not true. So we probably have to handle that. Maybe it is true. So it is exactly 4 times 60. Okay. But our register history has one. So our register history has. When you ask for the ith element of the register history, it gives you the beginning of that cycle. Is the issue. Yeah, we're getting 1 extra because we have cycle 0 in here. Let's see here. Chandy says C#10, just we'll take a look. Maybe you like it. Yeah, maybe so. Has your VS Code showing all the types? It's the standard Rust. Which one is it? I think it's Rust Analyzer. I think it's this one. And that does it out of the box. Might be Rust format, but I don't think so. Yeah, I'm pretty sure it's that one. It's super nice though. It's really helpful. Okay, so I need to work out what the behavior is. So start cycle 1. It draws a pixel in position 0. Yeah, so I think this is my 0 index is the problem. the start and end thing is nitpicky. Right, so in my test I had no op, add 3, add 5, and that does, this is start 1, and 1 start 2, and 2 start 3, and 3 start 4, and 4 start 5. And that's why the 3 doesn't show up until, wait, shouldn't the 3 show up here? Zero, 1, 2, 3, and it's only at cycle 4 is the point that the add X actually changes. So basically as though my register history is 1 indexed. So I just chop off the first, I just ignore the first value. So let's skip 1 and see if that does it. Still explicit panic. How long is this register? We expect it to be 241. Is it 242? Yeah, it's going to be 242 because the last instruction is going to write something. Begins executing. Finishes executing. During cycle 1, it does draw the position. During cycle 2, it does draw the position. Should probably just put a test in for the first few of these. It's gonna fail my assertion though. So let's see if we can just do it with the debugger. Usually I would try to test this better, but I feel like it's going to be a little bit painful. And what happened? Certainly we get to the point where we render. Okay. So CPU, register history. And it panics. What if I have it not panic? Then I would need to give it behavior. That behavior is going to be undefined. We don't want that. Why? Register history, enumerate, self.push. I guess the issue, I guess it can get to be more than 40. Is the thing. It can get to be more than. No, it should never get called though. In that case. So let's just jump in here and see what the behavior is. Okay, so length is 6. The output screen is empty. Is lit is true. And that's because we are using the larger example, and so that matches. So next to add, we expect to be 0. Whoa, it immediately panics. It immediately panics. Okay. Well, that's not expected. Oh, wow. This needs to be not equal to. That's really bad. That's really bad. Okay. And it's still hitting the explosive panic. But now at least is it getting in there. Okay, there we go. IDX is 0. Get rid of this one. Then it panicked. Why are we panicking the second time? Cool. IDX is 0. Now are we trying to push? Pushing should be fine. Okay, so now length. One of them has 2 things in it. Everything else is empty. That seems correct. Okay, 3 things. Okay, but that's wrong. We should not get to 3 things. It should be 2 and then a dot. Instead, it's 3 and a dot. Okay, it's doing something though. Okay, it's just off by 1 because I think I didn't have to skip after all. Where was that? Didn't I skip somewhere? I got rid of the skip. Yeah, undid the skip. Skip 1. Okay. Fails, but it fails because I told it to fail. So let's see. So the answer it outputs is this. Oh, I pasted these in. Okay, so we've got the correct first row, and then everything else is getting blanked. Making progress though. So push, get next add. We check if it's lit. Okay. Register history. Into iter, we skip 1. And we ask whether x is close to I. Seems right. So why self that push? Seems like push is going wrong somewhere. Pushing the right number though. This is 40. So somehow it's getting get symbol is false every time. But I definitely has the right length. So what to say here? During cycle 21, spread is 3 wide. There's no such thing as vertical position. Position where the CRT is currently drawing. Then those pictures will be drawn. Pixels will be drawn. You count the pixels. Single pixel during each cycle. Sure. And we know my example is the right length. So what's happening after 40? What's happening after 40? One, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those. Probably use a conditional breakpoint or something for this, but that's 9. That's 10. Length is 40. Good. Okay, so now what happens? So it's false, but it should be true. So what is... the problem is I can't see what the state of the register history is. If I pop out of this and I look at register history, want to be able to see what's going on with the CPU there. I guess I can stop it here and just look at CPU. So CPU register history, unable to read, optimized away. CPU, it's optimized away. Okay, CPU, register history has like 241, that's what we expect. Whoa, and this is garbage, right? CPU, register history, 241, okay. 1, blah, 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 blah. Then at 40, somehow it's back at 1. 226. Oh. That's what it's meant to be. Ah, this is a misunderstanding of how the puzzle works. Okay. Okay, so position 0 and position 39 are on each row. Got it. Okay. That should be easy to fix. Okay, so this doesn't quite work. Is lit. So we can just do I mod. Is it I? Yeah, I needs to get modded. So we can just do I mod 40 as I32. And okay, and it passes. Good stuff. And so now we look at problem B. Okay, it's trying to tell us an answer, but we can't see what it is. So let's take a look. That's not it. How do I copy out of here? Okay, that looks more like it. And we can just looks like that, and that says ZG. Wow, that's hard to read. ZGCJZJFL. ZGCJZJFL. Yeah? ZG. C, J, Z, J, F, L. Yeah, that's what it is. Okay. So let's take this and we can say toString here, and now this can be what we paste into our problem output. And we'll just say let expected be back this. Now this becomes expected. All right. And this becomes the answer. Dope. All right. Cool. That was problem 10. That was a lot of these. It's really about very carefully reading the question, which is a good skill to be teaching and not always one that I have. Okay, let's do problem 10. Or 11. Day 11, monkey in the middle. As you finally start making your way upriver, you realize your pack is much lighter than you remember. Just then, one of the items from your pack goes flying overhead. Monkeys are playing keep away with your missing things. To get your stuff back, you'll need to be able to predict where the monkeys will throw your items. After some careful observation, you realize that the monkeys operate based on how worried you are about each item. You take some notes, your puzzle input on the items each monkey currently has, how worried you are about those items, and how the monkey makes decisions based on your worry level. For instance, okay, test divisible by 3. Okay. Ugh. Okay. Each monkey has several attributes. Starting items list your worry level for each item the monkey is currently holding in the order they will be inspected. Operation shows how your worry level changes as that monkey inspects an item. An operation like new equal to means that your worry level after the monkey inspected the item is 5 times whatever. Okay. Test shows how the monkey uses your worry level to decide where to throw the item next. Okay. After each monkey inspects an item, but before it tests your worry level, your relief that the monkey's inspection didn't damage your item causes your worry level to be divided by 3 and rounded down to the nearest integer. Okay? The monkeys take turns inspecting and throwing items. On a single monkey's turn, it inspects and throws all of the items it is holding, one at a time and in the order listed. Monkey 0 goes first, then 1, then 2, so on, until each monkey has had a turn. The process of each monkey taking a single turn is called a round. When a monkey throws an item to another monkey, the item goes at the end of the recipient monkey's list. A monkey that starts a round with no items could end up inspecting and throwing many items by the time its turn comes around. Okay. If a monkey is holding no items at the start of its turn ends. Okay. After round 1, monkeys are holding the items with these worry levels. Monkeys 2 and 3 aren't holding any items. Process continues. Okay, chasing all the monkeys at once is impossible. You're going to have to focus on the 2 most active monkeys if you want any hope of getting your stuff back. Count the total number of monkeys each monkey inspects items over 20 rounds. In this example, the 2 most active monkeys inspected at 101 and 105. The level of monkey business in the situation can be found by multiplying them together. Figure out which monkey to chase by counting how many items they inspect over 20 rounds. What is the level of monkey business after 20 rounds of stuff slaying simian shenanigans? Say that 20 times fast. Okay. Interesting. Kind of like I like this problem on the face of it, but I'm worried that it's going to be a little bit tedious to implement. But We will see. Okay. So, how to approach. Oh, there aren't very many tests. Okay, so we can manually inspect these, which is nice. So there's 7 monkeys. They have some items that they start with. They have an operation that we need to parse. It is always either plus or multiply. And then they have a test, which is always divisibility by something. And they throw to different monkeys depending. Okay. And the way the rounds work is after each monkey inspects an item, but before it tests your worry level. Your relief that the monkey's inspection didn't damage the item causes your worry level to be divided by 3 and rounded down. Okay. The monkeys take turns inspecting and throwing items. On a single monkey's turn, it inspects and throws all of the items it is holding one at a time in the order listed. A monkey that starts a round with no items could end up inspecting and throwing many items by the time its turn comes around. Sure. Okay. Okay, so seems like we're going to model this as 7 monkeys. Each monkey has some data associated with it. And it can pass things around in a monkey pool, basically. Okay. So, let's go. Sorry about that. Hit a bad keyboard shortcut. Okay, so it's back. Let's get rid of that, and let's go to problem 11. Let's get rid of the shortened inputs because we don't use those anymore. And let's see. So, test monkey. Actually, before we do that, test monkey pool. Executes round. Something like that. But let's first do the example. So the example is this. Example monkey config. We can put it up top. Get example monkey config as, I guess, a vector of strings. We're going to end up using our parser again for this, I'm pretty sure. So let's just get it as one big string. And it will be, you know what? Let's throw it in a file. Example input 11. And it's not that, it is this. Come And so now get example monkey config can just be input parser new parse into single string example input 11. Okay. And so then this will be assert that get example monkey config solve problem 11a is 10605. Get example monkey config. Oh wait, that returns us true. That wasn't what we wanted. We want solve problem A. Oh yeah, no, that was what we wanted. But this needs to take a string. And this needs to take a string. Okay. And this will be parse to single string, as will this. And we will need to be able to parse into a bunch of monkeys. We will need to be able to have them execute around, and so on. Say unimplemented here. Test monkey. We need a parser. Test parses into monkey pool. So something like let pool be monkey pool from string of example monkey config, and then we say assert that the number of monkeys is 4. And I guess we can assert something about the monkeys. Let monkey, I don't know, let's just assert some slightly random things. Maybe let monkeys equal pool dot get monkeys. Assert monkeys 0 dot get items. The worry level of each item. I'm okay with indexing things by the worry level of each item. I guess so. 998. Check that the last monkey 3, has the right items. 74. let's check that monkey 2 or monkey 1 dot operation of 5 should be 11. Let's check that monkeys 2 dot test of 13 26 should be true. Let's assert that monkeys 3 dot test of 4 should be false. And let's assert that monkeys 2 dot get destination true is 1, and monkeys 2 dot get destination false is 3. Okay, so that'll be for the parsing. For the pool, we can say this same thing, and then we don't need that quite yet. We say pool dot execute round, it needs to be mute, and then we need asserts. Let monkeys equal pool dot get monkeys, and monkeys 0 has 20, 23, 27, and 26. Monkeys 1 has 2080. Really? Okay. 2080, 25, 167, 207, 401, 1046. And then the other two, 2 dot length 0, and same thing with 3. Okay. And I guess I can do pool dot execute rounds, 19 more rounds, and we can do the same thing. But now it's 10, 12, 14, 26, and 34. This is 245, 93, 53, 199, and 115. Okay. And those are still empty. Cool. Okay. Okay. These seems like pretty good tests to get started with. We can write some other more specific ones if we need to. But these will these should do the trick to start off. Okay, so we're gonna need a parser. And we have that parser from problem 8. Or 7. It was 7. Yeah, 7. Okay. So I basically want to reuse this parser. Where is it? I put it in input already. I did not remember that I did that. Wait, so is this already generalized? Oh no, this is input parser. That's not the thing I'm interested in. It's command stream parser, command stream, command parser. Okay. So this has parse command in it. Doesn't generalize. Parse command results doesn't generalize. Everything else does though, I think. So what's the best way to extract this? What's the best way to extract this? This is like kind of nice. Guess what I'll do is I'll copy this whole thing out, and then so let's put it. Let's see here, in input, not an input, in this input or utility. Let's say utility. Let's create a new file called parser.rs. In mod.rs, we need pubmod parser. And then from problem 7, we will take all of this. And really, if I were doing this really right, I would I'd re-implement the command parser in terms of the parser I'm about to create. But I don't want to do that because it's going to take time. So now in parser, let's just paste this to start with. And we'll call this parser. Parser. Let's call this toParse. Remaining to parse works. Increment pointer works fine. Parse works well, except that we can't return a command stream. what we want to I kind of don't want parse to be a thing. So let's just get rid of this and get rid of this and get rid of this. And just keep... Whoa, what just happened? Keep all of this, but get rid of these. And we just keep the ability to like peek and consume until and all that good stuff. Yeah, and now nowhere in here should we say anything about command, which is not found, which is good. Okay. I think this is good because now in problem 11 we can say what? We can say derive just clone and debug for struct monkey pool monkeys of monkey and impl monkey pool, and then we will also derive a bunch of stuff. In fact, it can even be hash for struct monkey, and a monkey has items, which is a vec of U32s. It has an operation. Is that what it's called? It has an operation, which we'll define, and it has a test divisor, which will be a U32, and it has a true destination, U size, and a false destination, U size. And so we can impl the monkey, and we can say pub function new items, on all this stuff. Returns a self, and it's just self of all this stuff. Curious if Vim people just like record a macro to do something like that. Reuse multiple cursors. I don't quite know what the best approach is to do something like that. Okay, so pub function new does that. Pub function gets, what are all the things I said at the bottom? Get items, operation. Okay. Get items. Self should return a vector of U32s. self.items.clone, pub function operation, applies to some U32. Yes. And gives back a U32. And we'll have to match on the operations there, so let's derive everything except default. We can derive hash, because why not? Enum operation, and this can be add U32 or multiply U32. And this can be pub function apply self some U32 returns a U32, and this will be match self add m, then n plus m, otherwise multiply m is n times m. Okay. And these need to be self. Okay. And so now doing the operation just amounts to saying self.operation dot, let's say apply operation here, I guess. Apply operation. Dot apply n. Yeah. Yes. Okay. What else? There's pub function test self n, and that returns Boolean, and this is just n divided by self dot test divisor equals 0. That's what it means to divide something. And then pub function gets, what was the last thing? Get destination. Cool, and we return a U size here because it's going to be the index of a monkey, and it's if b then self dot true destination. Oh, it needs a self also. Destination, otherwise self dot false destination. And okay, so now the monkey knows how to get its stuff. It's kind of just a value class. It doesn't like being copied because it has vectors in it, which is fine. I can manually clone it. Cool. And then a monkey pool should probably know how to instantiate itself. Pub function new. Monkey is a vec of monkey. Should return a self, which is just self monkeys. And then the tricky bit is we're going to need to be able to instantiate it from a string, and that's where we'll use our parser. So string will return a result. Should we just panic if it can't parse? I feel like I've been good on previous problems of like doing it as a result and not panicking, but honestly I think it makes it harder to debug, and it's not like I'm not in control of my own errors, so let's just have it panic. Shandu says, for a very long time you're in the dilemma of building stuff versus solving problems, like leak code, having to code stuff. Initially you got into coding so that you can build stuff like servers, but now you want to build web apps and solve some weird business problems, solving problems, and implementing, made me really good at coding stuff. Yeah, I mean, I think that's the thing, right? Problems don't look like they're actually important on the face of it, but they let you cut through a lot of the stuff that you have to deal with that's really important in real world business problems. But it's just then, I was like, should I return a result from my from string function so that I can cascade my errors up to the caller? It's like, in any business environment, of course I should. That's really important. This is not a business environment. I am writing this. I'm going to run the function. If it fails, I'm going to debug it in an IDE. And to kick results around is just being a little bit, whatever, overly subscribing to, the overly formal in some sense. And so by getting rid of that formality, you can learn a lot about the craft of coding. And then when you have to apply it in business, like, yeah, you have to learn a bunch of other elements of the craft of coding. But you've gotten to separate out your concerns. So true. It made you a good programmer, though. Yeah, I mean, both of them make you a good programmer, right? Like, you have to do things in the real world. You have to be able to handle those real world pragmatic concerns. But you also have to be able to write code that solves a complex problem. And if you try to do both at the same time and learn both at the same time, it's not going to work. So I'm an advocate of doing both. I also think just doing, like, programming more makes you a better coder, and it's more fun to do problems than it is to, like, I don't know, I don't particularly enjoy, wiring up servers and trying to get them to do things unless I have a business reason to do it. I need that extrinsic motivation, whereas with these problems, they're just fun, and I'm happy to do them just for the sake of doing them or helping people understand how to do them. But yeah, totally agree with you. Okay, so we need to parse this. So we will say let parser be parser new s, and we're gonna have to pull in parser. No code actions available. Is that not what I called parser? I called it parser. Is it in my mod? It is in my mod. Skeptical though, because I'm getting no red lines in here. Maybe? No. Alright, what if I try and import it myself? Use create utility parser. Oh, I forgot to make it pub. That's what it is. Okay. Okay, so we pipe it into our parser, and now we're just going to want to expect monkeys until we run out of monkeys. So can we do while let some maybe header, or I guess it always will be a header, monkey header. b parser dot increment pointer. Don't I have like an expect something? Don't remember my own API. Blah blah blah. Oh, some of these are going to need to be made pub. Oh, and this shouldn't be a thing. Consume until white space is fine. Consume remaining is fine. Consume n is fine. Expect end of line or file is fine. Expect end of line is fine. Okay, these should all be good. Okay. So now I should be able to consume a line will always return a string. I can expect and I'll get back a result. Okay, so while okay, parser dot expect monkey. Is that what the first one is? Yep. And in fact, it's monkey space. So let's expect monkey, and then we'll say we know for a fact that it's always only one character to index the monkey. So actually, we can just push the monkeys on. We know that they go in order. So we can expect, and then we can say let monkey number, which we're not actually going to use, be parser dot consume line we'll say let starting items header be parser dot expect it would be nice to be able to consume white space. Can we do that? Parser dot consume until white space. I want consume all white space. So let's say consume white space. Let's let some white space be this. And then we expect starting items, and then let's say let starting items be parser dot consume until white space dot split on commas, comma spaces dot collect as a vec. Okay. And then we'll do the same for operation. Similar thing for operations, similar thing for tests. Let's probably throw this into a function too. So let's call this consume or parse. Let's say consume. Consume is better. Starting items and returns a vector of U32s. And so in fact we should also pipe these into what, s.parse into U32s, and does this return a, forget what parse returns if it's a, but anyway, we can expect parse should be able to parse item number. And yes. Okay. And we need the parser here. Can it just be a reference to the parser? A mutable reference to the parser would work. And then this just becomes like that. And we can say let starting items be self consume starting items parser. Yes. What did I miss a thing? Consume starting items. Oh, at mute. Okay, we'll have to implement consume whitespace. Expect doesn't exist on. Oh, do I have to format this? I guess I have to format this. No? Expected string found through, okay. Okay. So let's go implement parse whitespace or consume whitespace. Pub function consume whitespace and itself returns a string. Let's turn this into a const. Oh, it can't be a vector then, though. Okay, let's have it be a private function. Whitespace chars returns a vec of character, and can just return this. A hash set of characters, sure. Okay, and then this can be self dot whitespace chars, and let's be a function. Okay, and now consume until whitespace characters can be yeah, it's basically the same function, but so if we want to, maybe the nicer way to do this is to say pub function consume until we take a mute self and we take a function condition, which is a function from what to what? A character? Yeah. Is a function from a character to a bool, and the whole thing returns a string. And then we can basically use this as the recipe. So now instead of having this, we say condition of C. We return, otherwise we keep consuming. And now this whole function just becomes self.consume until ch, because otherwise I think it's going to get mad at me because I'm trying to I'm trying to pull a variable from outside. Self white space chars contains at ch, and this just goes, all of these go away. Consume until, okay, and it likes that, and then this ends up being the same thing, except that it doesn't contain. Consume until, wait, that's backwards. Consume while. Consume while is the better name for it. Okay. Cool, that's nice, I like that. I like that. So back on problem 11 land, we can now consume white space, which is great. And so let's then say let operation be self-consume operation, parser s. Let's, what is it, test. Let's let test divisor true, destination false, destination be self.consume test parser s. And now we say, let's see here, let mute monkeys be an empty vector up here, and now monkey, let monkey be monkey new starting items operation test divisor true destination false destination monkeys dot push monkey. And at the end of it we return, at the end of it we say self dot, we return self new of monkeys. Hey, a lot of lines disappeared. That was nice. Okay. You don't think that we are returning? Yep, that's fair. It's because I didn't. It's because I ended the statement. And it doesn't like borrowing this as mutable, does it? Can I just do this? Consume, oh, I haven't written that function yet. That's fine. Get this out of the way. These all need to be at mute. And consume operation parser s string back is that a u32? No, it's an operation. Okay, so for operations, what are we doing? What are we doing? Okay, so we're going to expect, so we're going to say, oh, hang on. Also, we want this to happen out here. Consume until white space, and maybe let's say, let's starting items, and then we'll say parser.expect end of line or file. Expect we should have hit the end of a line or file. Actually, it's really just end of line. And then return starting items. At the end of this, we should say parser.expect. I mean, really, it's the end of the file, but the end of the file. Okay. Okay. I have like 10-15 minutes left. So let me just write these two quickly, and then we will call it. So operation header is parser dot expect operation colon space. Oh, I'm just gonna unwrap these since it's already an expect. It's pretty clear what it's doing. And then and actually we can just expect new equals old space. And then we say let operand be parser.consume n of 1. We can say let white space parser.consume white space, and then let n be parser.consume until white space. Parse u32 dot expect and should be parsable into u32. And we format this. actually say that. Okay, fine. Let's say in string, and then we'll say let n be this. And string and n string. Okay, and then match operand. If it is a plus, what does this return? Returns a string. If it's a plus, then we say operation add n. If it's a times, then we say operation multiply n. If it's anything else, then we panic and we say invalid operand. And that's what we return. And we don't like this. This is a string. I'm not allowed to do this. Can I just do this? To string. Oops, as string. Okay. Operation. Use undeclared type operation. Do I have a typo somewhere? Enum operation, impl operation. I'm missing a. Okay. So that's consume operation. And now we need consume test. Consume test. Parser needs to be a meet parser. S is a string, and it returns a U32 and 2 U sizes. Oh, and we should let to return equal this. We should hit the end of the line. And then we should return to return. Whoa, what happened to my let to return? Did I say that already? Do I need to consume white space there? I don't think I do. Okay. And so this one will be let test header be parser.consume .expect. Test divisible by then we need to consume until the end of the let. Hold on one moment. I'm sorry. I need to drop. We'll pick this up next time. Thanks for watching.